Hi everyone, welcome back. Hello. Good afternoon, everyone. Welcome to PW NEET English and welcome to one short lecture of Center of Mass and Rotational Motion. Good afternoon, everyone. Let me know in the chat box if I am clearly audible. Be quick. Hi everyone, hi. Good afternoon. I am all good. How are you? Hi Zainab, hi Yash, hi Karthik, hi Sankar. Hi Casper, good evening, good afternoon, sorry, good afternoon. It's good afternoon. Hopefully all of you are doing fine. Let's quickly start today's class. All right. Today's class is slightly special because mostly in physics we only talk about numericals. In today's class we are going to do numericals, but we are going to also complete theory plus questions. So let's suppose if you have any doubt in any concept of center of mass and rotation, after this lecture that will be over. I'll try my best to cover each and everything, but surely we'll start with the most important topics. We'll start with those questions which generally come in NEET exam, right? And let me tell you, the level of questions is going to be absolutely amazing, and this lecture will be more than sufficient for you to complete center of mass and rotation, right? In the very start I am saying the level of the question is going to be above moderate level, so do not get demotivated after seeing the questions. Watch the entire lecture, right? After this lecture most of your queries regarding center of mass and rotational motion will be cleared. So without any delay, let's start, my dear friends. If you have any doubt, you can write down your doubt in the chat box, right? We are going to start with the concept of center of mass. And see, we all know the definition of center of mass. Definition of center of mass is it is an imaginary point where the entire mass of a body can be assumed to be concentrated, right? Can be assumed to be concentrated. Now we have got two types of distribution of mass. First is discrete distribution of mass. First one is, my dear friends, and then I'm going to quickly move to questions also. Do not worry. Mostly we are going to solve questions only, right? So do not get worried. Let's quickly revise whatever we know about this chapter. So first of all, we are going to talk about discrete mass distribution. Discrete mass distribution. In this, my dear friends, let's suppose that you have got some point masses m1 over here, m2 over here, m3 over here, and so on, mn over here. And the position vector of these masses are r1, r2, r3 and r4, right? So please note these are r1 vector, this is r2 vector, this is r3 vector, and this is rn vector. So if someone is going to ask us about what is going to be the RCOM, that means, let's suppose, my dear friends, I am considering these as system of particles. I am considering these as system of particles. So RCOM will be simply written as M1 R1 plus M2 R2 and so on, plus Mn Rn, and then whole divided by M1 plus M2 plus M1 plus M2 plus Mn, right? Now the next thing is how to find out XCOM. See, RCOM can be also written as, so these are basically the same things. RCOM can be also written as XCOM I cap plus YCOM J cap plus ZCOM K cap, right? We are going to write something like this. Right now I am not discussing continuous mass distribution. Let's quickly complete this, right? So let's suppose I am saying that center of mass is somewhere over here. Center of mass of this body is somewhere over here, and this is going to be the position vector of center of mass. This is going to be the position vector of center of mass, right? Position vector of center of mass. And similarly, we are going to find, you guys know that we are going to find out XCOM, we are going to find out YCOM, and then we are going to also write ZCOM. We are going to talk about these things also, right? Clear? So XCOM will be written as M1 into X1 plus M2 into X2 and so on, Mn into Xn whole divided by M1 plus M2 plus Mn. And similarly, you are going to also write for YCOM and ZCOM, right? So this was your revision, right? This was your revision. Now let's talk about some of the numericals related with it. So I'm going to only invest 5 minutes into theoretical part, and quickly I'm going to move to numericals so that your main objective for today's class is clear. Okay, just a second. All right. Let's suppose this is the first question. Let's suppose this is the first question, right? In this question, they are saying we have got two particles, 1 kg and 3 kg, and they have position vectors r1 and r2 respectively. Then position vector of center of mass will be. So position vector of center of mass is going to be, my dear friends, masses are m1 1 kg multiplied by 2 I cap plus 3 j cap plus 4 k cap, and then you have got 3 kg multiplied by minus 2 I cap plus 3 j cap and minus 4 k cap, right? And then you have got divided by sum of masses, that means 4 kilogram. So finally you are going to get, okay, just a second, finally you are going to get 2 I cap and you have got minus 6 I cap. Then you have got 3 j cap and you have got plus 9 j cap. And then you have got 4 k cap and then you have got minus 12 k cap and divided by the total mass, that is 4, right? 1 plus 3 is 4. So we can quickly write down the answer. This is going to become minus 4 I cap. That means my final answer will have minus I cap, right? This will become 12 j cap and this will become minus, my dear friends, 8 k cap. If I'm going to divide it by 4, this will cancel out, this will become 3 and this will become 2. So answer will be minus I cap plus 3 j cap minus 2 k cap. So minus I cap plus 3 j cap minus 2 k cap, minus I cap plus 3 j cap minus 2 k cap. So D is the correct answer, right? Clear? Hopefully everything is sorted, very easy. Now let's increase the level. Obviously this is not moderate difficulty level, but please understand that whenever I am going to solve first few questions, those are going to be, you guys know how things move, right? We are going to start with some easier problems, then we are going to definitely move to some difficult problems, right? So okay, so now we have got this as our next question, right? This as our next question. Center of mass of a body lies outside of the body, may lie within, outside or on the surface of the body. This is absolutely correct, right? We have got various such cases in which center of mass of a body can also lie outside of the body. For example, as let's suppose something like this, right? Clear? Right? It will lie outside of the body, so it may lie within, outside or on the surface of the body, right? Clear? Then Let's solve this one. Let's solve this particular problem, my dear friends. Okay, let's solve this particular problem. Be quick. I want you to attempt this question with me. My dear friends, in these types of problems, first please understand, either they are going to themselves give you the coordinate system, or they will ask you to find out the center of mass from a particular object. In this particular case, they are saying to find out the center of mass from 4 kg. So this is m1, and x1 and y1 are 0, 0, 0, 0. This is very simple. Let's drop a perpendicular down. This is sine 37, this is 5. We know that sine 37 will be perpendicular, and perpendicular is, mind you, y, and divided by hypotenuse is 5, and sine 37 is nothing but 3 by 5. So this becomes 3, right? Obviously you can quickly do it by simply saying, sir, tan 37 is 3 by 4, and this is a triplet. I know that, right? So you can write this thing as 4. So the coordinate becomes 4, 3. The coordinate become 4, 3. The coordinates become 4, 3. So if the coordinates become 4, 3, now the XCOM will be m1 into x1 plus m2 into x2 whole divided by m1 plus m2. That means 4 plus 2 is 6, right? This will become 0. This will become 3. That means XCOM will come out to be 4 by 3 meter. And YCOM will come out to be m1 into x1, 4 into 0 plus m2 into, m1 into y1 and m2 into y2 whole divided by again 6. This will become 2. This will become 1. So 4 by 3 comma 1 meter is the correct answer. 4 by 3 comma 1 meter is the correct answer, my dear friends, right? All right. Now moving on to the next one. Let's solve this particular question. If some of you remember, this question is from one of the mock paper, right? Let's do it. Clear? In this question, my dear friends, first of all, see, whenever they are going to give you Cartesian plane, you will have to find out the center of mass with respect to origin, from origin, right? So this is origin, right? Let's say this is m1, this is m2, this is m3, this is m3, right? Now the next thing is going to be to find out the coordinates. The coordinates of this one is going to be minus 20 comma 0. Now understand, this is 10. So if let's suppose this is y, right? Or let's say this is y1. So you are going to simply say y1 will be equals to sine 37 multiplied by 10. Am I correct? So sine 37 is 3 by 5 and times 10. So this will become 6. So y is at least 6, and as far as this thing is concerned, that means x is concerned, let's also write down the value of x1. So x1 will be cos 37, that is 4 by 5 times 10. So this is going to be 8. So coordinates are, I believe, 8 comma 6. Coordinates are, I believe, 8 comma 6. Hold on, if you have already done this problem, wait for some time. I have got various new problems, and I'm pretty sure you have never seen these types of questions from center of mass, and these are going to be absolutely appropriate for your RE-NEET exam. So hold on, right? Next thing is, my dear friends, to find out the coordinate of this also. Now let's suppose this is y2. So y2 will be, my dear friends, sine 53, that is 4 by 5 multiplied by 10, and that's going to be 8 centimeter. If you are going to talk about x2, so x2 will be 3 by 5 times 10, and that's going to be 6. That's going to be 6 centimeter. So coordinates of this are 6 centimeter minus 8. Please mind the signs also. Now if we are going to talk about XCOM, we are going to simply write this m1 in, this is 1 into 0, so this becomes 0, so 1 kg, not 0, sorry, 20, 1 into minus 20 plus Then you have got 2 into 8, 2 into 8, then plus you have got 3 into 6, 3 into 6, and then whole divided by 1 plus 2 is 3, and this is going to become 6, right? So this will become minus 20, and this is 18, and this is 16. So minus 20 plus 16. Sorry, this is 16. Yeah, that's what I have said. So this will become minus 4, and this is 18, and divided by 6, right? So this will become 14 divided by 6. I believe answer will be in fraction. So this will become 7 by 3 centimeter. So XCOM will be 7 by 3 centimeter. We have got only one option. So I think D will be correct. Now I want you to find out YCOM by yourself, right? I think I can move on to the next problem. Okay. So let's solve a new problem. Okay. Great. All right. All right. Let's solve this. A nice question. Everyone, hopefully you guys want to attempt it. I'm going to start the timer. 90 seconds. Let's start. Read this problem. This is going to be new for you. All right. Let's begin. Quick. Oh, I'm sorry. This is easy. Sorry. This is easy. This is easy. By mistake, I have given you this question. This is not difficult. Apologies. This is very, very easy. Let me tell you that problem. This is very easy. You might be also thinking, what has happened to sir, right? He's saying that this question is very difficult. So now, first of all, please understand, this is one of doubt of many students. They are saying that find out the position of center of mass from center A. Got it? So this is our origin. Hopefully this thing is absolutely clear to you. Please understand that this thing is origin. That means this is your x-axis and this is your y-axis. Clear? And masses are m. So mass m, and mass m. So this is 0, 0. This coordinates are going to be, this is r and this is r. So this is going to be 2r, 0. And this is going to be, my dear friends, this is r. Got it? And then this is also 2r. So this will become 4r, 0. R plus R 2R, R plus R 2R. So this is 4R. So this will become XCOM, and we'll only have XCOM because it is symmetrical about y-axis. We'll have m into 0 plus m into 2R plus m into 4R and whole divided by 3m. Right? I believe masses are absolutely same. So this will become, my dear friends, first of all, m will get cancelled out. This will become 6r divided by 3, and this will become 2r. All right. So I actually, by mistake, I told you that this question is nice. No problem. Let me tell you the nice problem. Although only 60% of you have got it right. Now I think everything is clear, right? The important point is this. From center of mass of A. So I'm sorry, we have to find out the position of center of mass of this system of particles from A. Now let's start. Let me give you that problem which I was talking about. Yeah, this one. Okay, this is a nice problem. Let me read it. Yes, this is what I was talking about. Now let's start this. 4 particles of mass m, 2m, 3m, 4m are arranged at the corners of a parallelogram with each side equal to A, and one of the angle of two adjacent sides is 60 degree, right? It is 60 degree. So other angle will be 120 degree, right? The parallelogram lies in the xy plane with mass m at the origin and 4m on the x-axis. Fine, clear. The center of mass of the arrangement will be located at. So obviously we have to find it with respect to origin, right? Come on, let's do it. Let's do it, my dear friends. See, let's suppose this is how we are drawing a parallelogram. Done. Now they are saying that mass m, ठीक है, वो तो that's absolutely fine. We are more interested in m is at origin. So m is at origin and 4m is on the x-axis. So 4m is over here. So which means that after m, 2m will be somewhere over here and this is going to be 3m. This is going to be 3m. Clear? This angle is 60 degree. This angle is 60 degree. All right, this angle is 60 degree. Clear? -60°. Coordinates, if you are going to ask me, sir, what are the coordinates? This is 0, 0. Edge length is, my dear friends, edge length is A. So the coordinates of this will become A, 0, right? Now we have to find out these values. So first of all, this value will be A cos 60. This is A. So this will be A cos 60 degree. That means A by 2. Which means that the x coordinate of this will be A by 2. X coordinate of this will be A by 2, comma, this will be A sin 60. So A root 3 by 2. This will be A sin 60. So this is going to be A root 3 by 2. My dear friends, y coordinate will remain same. X coordinate will become, this is A by 2, this is A by 2 and this is A. So this will become 3A by 2. And y coordinate will remain same, so that means A root 3 by 2. Is it clear? My dear friends, hopefully this is all sorted. This is going to be A cos 60. Now you have to be a little quick. Please do not write like sin 60 is equals to perpendicular upon hypotenuse cos 60. You will waste a lot of time. This is A cos 60, this is A sin 60. If this is A cos 60, that is A by 2, and this length is A, so this total length from here till here, kindly note, from this point to this point, the distance will be A plus A by 2. Because this much length is A by 2, this much length is A by 2, and this much length is A. Clear? So that will be A plus A by 2, that is 3A by 2. Can you please quickly write down in the chat box if everything's clear, right? And after this, if everything is clear, then I'm going to write down XCOM for you. M times 0 plus 4M times A plus 2M times A by 2 plus 3M times 3A by 2. 3M times 3A by 2, my dear friends, whole divided by sum of masses are, this is 5m and that's also 5m, that is 10m. This becomes 0, m can be obviously cancelled out, 2 can be cancelled out. We'll get something like this, 4a plus A, that is 5A, plus 9 divided by 5, that is 4.5A, whole divided by 10. If I am not wrong, I can write this thing as 5. So this will become this will become 5, so this will become 9.5. So 9.5A, that means finally answer will be 0.95A. So that's your XCOM. That's your XCOM, and I believe there is only one such answer, that is option B. Obviously, we can also find out YCOM. YCOM will be M1 in this will become 0, so I am not writing, that will become 0. Got it? See, chalo, let me write it for you. M times 0 plus 4M times 0 plus 2M times root 3A by 2 plus root 3A by 2 times 3M. 2 and 2 gets cancels out. Whole divided by 10M. This is 0, this is 0, this is root 3A, and this is 3 root 3A. Right? So that will come out to be root 3 by 4. Hopefully everything is clear. So correct answer for this is option B. Only 28.57 of you were able to solve this particular question, and that is why I have said this is a nice question, right? Absolutely fine. Clear? Yash, be quick. Let me know in the chat box. Yash, Henry, everyone, Robin, Sankar, Jaya, everyone, quickly. Zainab, be quick. Let me know in the chat box. If everything's clear with this problem, you guys want to solve such more questions, say yes or no. See, we are going to also complete theory. So I'm going to explain you one concept, and that concept is going to be one of important concepts, right? So we are going to first talk about concepts, and then we are going to move to questions. Henry, you can't hear what I'm saying? Okay, good buddy. Okay, now you have replied. Good, good Zainab, good Farzana, good. Jaya, do you care to answer me? Ananya, Ananya is saying I'm in a bus right now. Okay, that's really nice. If you're studying in bus also, that's good. Come on, clear? Now I'm moving on to the next one. Let me give you one more problem like this, and then we will move to continuous mass distribution. Again, first I'm going to explain you certain concepts, then we are going to solve some questions. This is again one of nice problems. Please see, a thin uniform circular wire is bent to form the two equal sides AB and AC of triangle ABC, where AB and AC are 5 centimeter. The third side BC of length 6 centimeter is made from uniform wire of twice the density of the first. The distance of center of mass from A is. This is a very nice problem. Let's start. 2 minutes. Let's begin. I'm going to help you in diagram with this diagram. See, the question is basically saying you have got a triangle like this, right? And we have got this as point A, point B and C. So AB and AC are same, that is 5 centimeters. So this is 5 centimeter, this is 5 centimeter. Clear? Next thing is, my dear friends, obviously these are 5 centimeter. Next thing, we want to find out the center of mass from point A. We have to find out the distance of center of mass from point A. We have to find out the distance of center of mass from point A. This is what we need to do. Come on. I've helped you with diagram. There is also one more important information. They are saying that it is made up of uniform wire of twice the density of the first, right? So the third side BC, they are saying that the density of this is actually 2 times of lambda. If let's suppose density of this is lambda and density of this is lambda. Here, this is what they are saying. Be quick. Be quick, my dear friends. I want you to solve. Okay, so many of you are saying B. fine. Let's check. Let's check. All right. See, if they are saying that you have to find it with respect to A, that means let's assume this is our x-axis. Let's assume this is our x-axis and this is y-axis. Sorted? Clear? Hold on. Please see, most of your answers are wrong. So that means you need to pay attention. My point is that center of mass of this AB will be somewhere over here. That means at the midpoint of this. Similarly for AC also it will be along the same line. Along the same line. Please see, my dear friends, it will be somewhere over here. Got it? Clear? Right? What I am trying to say is that if this is mass M, then this is also mass M. That means the x-COM, I am talking about the x-COM of the both of these masses are going to be somewhere over here. Not somewhere over here, but exactly in the middle. Am I correct? And that means x-COM will remain 0. x-COM will remain 0. Center of mass will lie on the y-axis. Center of mass will lie on the y-axis. Similarly, center of mass of this rod will be over here. So I only have to find out this y. That's it. I only have to find out this y. Clear? I only have to find out this y. Now, my dear friends, how to find this one out? See, this total length is 6 centimeter, I believe. This total length is 6 centimeter. If you are going to, if this is your y-axis, this will be perpendicular. That means this will be 3 centimeter. This is going to become 3 centimeter. Hopefully this is absolutely clear, right? Hopefully this is absolutely clear. This is going to be 3 centimeter. Now you can write down. Now you can find out this length. Now you can find out this length, my dear friends, and then you can apply the concept of the formula of y-COM. I mean, you can also apply the formula of y-COM. You can certainly apply y-COM. So you are going to write m1 multiplied by this length. So let's suppose the coordinates of the coordinates are going to be, kindly see, the coordinates are going to be x1 comma y1. Let's say the coordinates of this is x2 comma y2 and coordinates of this is x3 comma y3. So because I'm talking about simply y1, so I'm going to write y1 over here, then I'm going to write m2 into y2 and then I'm going to write m3 into y3 whole divided by m1 plus m2 plus m3. Right? Now please see, instead of m1, also one more thing, my dear friends, this length, can I find out this complete length? I think I can easily find out this complete length. This complete length will be under root of 25 minus 3 minus 9. So that means this will be 4. This is going to be obviously 4 centimeter because this is 3, this is 5, so this is going to be 4. If this is 4, then this is going to be 2. This is going to be 2. So that means I'm going to write, instead of m1, my dear friends, I'm going to write lambda times 5 times, instead of y1, I'm going to write 2. You can also write down minus 2 plus again lambda times 5. Again, we are going to write 2 plus, now instead of this we are going to write 2 lambda times 6, and then this complete length is going to be 4, and whole divided by total mass will be, my dear friends, 2 times of 5 lambda plus 2 lambda times of 6. I can cancel out lambda and I'll get 10 plus 10, that is 20, plus this is I believe 12, and this is going to be 48, whole divided by this is 10 and this is 12. So 10 plus 12 is 22. So this will become 68 divided by 22. If I'm going to cancel out with 2, so this will become 34 by 11. 34 by 11 centimeter. So all of your answers are wrong. Option A is correct. This is a very nice problem, right? Still you guys are saying 11 by 34. Now write down in the chat box. Everything is clear? Everything is clear? Be quick. Done? Come on. Because then we'll have to find out this. We have to find out the center of mass of these two things. This is one particle and this is another particle. Is everything fine? Quickly write down in the chat box. Option A is correct. Good. Nice problem. Be quick. 0%. 0. All right. Let's start. Let's move to the next one. Let's do this question. Let's solve this problem. You guys are happy with these types of problems? Be quick. Quickly let me know in the chat box. 90 seconds. Let's start. You have to find out as shown in the diagram, there are 5 identical rods. Length of each rod is L and mass M. Find out the center of mass of system from point C. From point C basically means, my dear friends, this is your x-axis and this is y-axis and it is passing through point C. That means this is origin. Be quick. Be quick. See, I'll also help you in this one. This is a rod. Each rod has mass M and length L. So center of mass will be somewhere over here. That is L by 2 comma 0. Center of mass will be somewhere over here of this rod. It will be 0 comma L by 2. Center of mass of this rod will be this is going to be L by 2 comma L. Is that right? Right, because this is L. Center of mass of this rod is going to be 0 comma, see, this is L and this is L by 2. That means this is going to be 3L by 2. Center of mass of this rod will be, kindly see that this x axis will remain same. This will remain same. So this will be also somewhere over here and x coordinate will remain same. So this will be L by 2. So L by 2 and this height will be L and this is L. So this is going to become 2L. Is that clear? Right? Fine. This means that if we are going to find out XCOM, we are going to get M1 into X1. Now mass is M into L by 2 plus M into 0, M into 0 plus M into again L by 2, M into L by 2, then again M into 0 and then again M into L by 2. Whole divided by these are your 5 rods, so 5M. M can be cancelled out. This becomes 0, right? So you will have 3L by 2. 3L by 2 and this is, so you will have 3L by 10. XCOM will be 3L by 10. When we are going to find out YCOM, now I think I can be a little quick. This is 0. So I'll start with this. Chalo, theek hai, fine. Let me also write this one. doesn't matter. Now you have got ml by 2 plus we have got m into, again, my dear friends, we have to look for y axis, right? So y is L, so m into L plus m into 3L by 2 plus m into 2L, I believe, right? That's 2L, and whole divided by, this is going to become 10 m. Obviously m will get cancelled out. Anyway, this is 0. My dear friends, L by 2 and 3L by 2 can be written as 4L by 2, that is 2L. 2L plus 2L is 5L, 4L, and 4L plus L is 5L. So we are going to get 5L divided by 10, that means L by 2. Is it clear? This means that RCOM will be under root of, I am talking about the magnitude of RCOM. Got it? The distance of center of mass from origin. So that will be square of 3L by 10, so 9L square by 100 plus, I think there is some mistake. Let's check it again, because I think we should get our answer as L. Divided by 5m. Obviously, you guys, I don't know why I have written 10L, but this is 5m. Sorry. So this is going to become 5L divided by 5m. Right, and m also gets cancels out. So you have got simply L. Now everything is cool. So this is L square. So you are going to get L under root of 109 divided by 100. 109 divided by 100. So option D is correct. Again, you guys were saying option A. Option D is correct. Clear? Let's check. If you have any doubt, do let me know. Be quick. Be quick. Option D is correct according to me. Yeah, what's the problem? Why 50? Why 50, my dear friends? This is L. This is 3L by 10. Am I missing something? Be quick. Come on. Close your chat and quickly let me know the answer. D is correct. Be quick. Be quick, my dear friends. Come on. Done? Is it clear, Henry? Robin? So why you guys are not able to solve questions like this? It means that you need this class, solve some questions like this. Please understand, we are only talking about the very first topic of center of mass, and this is actually one of the important topic, right? So please note, do not do any silly mistakes. Solve questions like this with me and you will be good to go. I think I should give you one more problem like this. I should give you one more problem like this. Come on, let's solve this question. Let's solve this question, my dear friends. Let's solve this problem. This is actually a nice question, so you'll have to pay a little attention to solve this. I'm going to help you with the diagram. The question is something like this. You have got a wall, right? See, we have got floor like this, and then we have got a wall like this. We have got a wall like this. Clear? And then we have got a brick over here. It has length L. It has length L. And then we have got another brick such that this is L by 2. This length is L by 2. This length is L by 2. And then we have got another brick such that this length is L by 4. This length is L by 4. Clear? And mass of each brick is M and length is L. And you have to find out the center of mass from the wall. XCOM, whenever they are going to talk about bricks length, they are simply saying that it has got no width. Come on, be quick. Solve this particular question. Solve this problem, my dear friends. Be quick. See, if I am going to say the center of mass of this brick is somewhere over here, that means this is going to be L by 2 comma 0. Now for the second brick, if this is L by 2, kindly see, if this is L by 2, this means that this is L by 2, which means that center of mass will be over here, which means that for the second brick, center of mass is over here and the coordinates are going to be L comma 0. Coordinates are going to be L comma 0. Clear? Now for the third one, it is really important. Kindly see. Kindly see, my dear friends. I know that this much length is actually, this much length is L. So this much length is going to be 3L by 2. Please see, this much length is going to be 3L by 2. This is L and this is L by 2. So this is 3L by 2. This is 3L by 2. Is it clear? This is 3L by 2. And this is L. This is L. This is L. Isn't it? This is L. Come on, be quick. What I can find out? Let me know. Can I find out this length? Can I find out this length? This length will be this length minus this length, right? If I'm going to subtract, if I'm going to, or you can say, this is actually interesting. This is interesting, my dear friends. This is interesting. Acha, this is also L by 4, right? This is also L by 4. Pay attention. This is also L by 4. Come on, let's solve. We'll have to think a little in this question. I'll start the poll. We know two things. We know center of mass of this rod. We know center of mass is this rod. We need to find out center of mass of this rod. We need to find out. We need to find out center of mass of third rod. I am also thinking, you also think. Be quick. Be really quick, my dear friends. Come on. Let's think how to solve this particular question. Be quick. We can do one thing. Whatever is the center of mass of this rod, it will be over here and this length will be L by 2. Kindly see, this length will be L by 2. This length will be L by 2. Let's remove this L for a moment. This is L by 2. Yes, absolutely. And this length is, that means I can find out this length. I can find out this length. Please see. I can find out this length. This will be, this is going to be L by 4 also. This will be L by 4 also. Is that correct? This will be L by 4 also. Be quick, my dear friends. Let me know. Question is really good. No doubt about it. And this is 3L by 2. This is 3L by 2 and this is, so 3L by 2 minus L by 4. So times 2 times 2. That means this is going to be 5L by 4. This length is going to be 5L by 4. This length will become 5L by 4. So center of mass of this will become 5L by 4. Let's check. This coordinate will become 5L by 4, right? And hence we are going to now write XCOM equals to M into L by 2 plus M into L plus M into 5L by 4 whole divided by, and then you have got 3 bricks, that means 3M. So M can get cancelled out and then I can multiply 2 over here. So I'll get 2L plus 5L, that is 7L, and divided by, I've got 4 and I've got 3, so that I'll get 7L by 12. 7L by 12. No, just a second. We have got one more thing to do. 7L by 12, right? What's the mistake, my dear friends? This is indeed a nice problem. That's going to be 5L by 4. That's absolutely fine. That's going to be L. Acha, I've got also one more L over here. I've got one more L over here. Sorry. I've got one more L over here. So this is going to become 4 and 4. Now let's find it out. So this will become 4. This will become 2L. Right? This will become, this is actually 2. So this will 6 and this is 11L upon 4 times 3 is 12. So 11L by 12. B is the correct answer. Really nice problem, my dear friends. B is the correct answer. Very good. Good. Right? Clear? So can we move on to the next one now? Is everything fine? Please identify this distance is going to be L by 4. If this distance is L by 4, you can find out this distance, right? Because this distance is going to be L by 2. Is it clear? Quickly write down in the chat box, my dear friends. This was again a nice problem. Now I believe I have told you questions related with point masses. I'm going to give you 1 or 2 questions in homework. Solve it for your practice. Solve this questions for your practice after the class, right? Solve this question for your practice and then we are moving on to our next topic. See, for our next topic, when we are going to talk about, this was center of mass of discrete mass particles. Now let me also explain some theory points to you. When we are going to talk about continuous mass distribution, the formula for center of mass will slightly change. We are going to write that XCOM will be written as, XCOM will be written as integration of X dot dm divided by integration of dm. Please see that we were actually, this is nothing but this is actually summation sign, right? This is summation sign, integration sign. We can also write this equation as, we can write XCOM as summation of mi xi divided by summation of mi, and I will have a range from 1 to n. So for continuous mass distribution, we are going to have this formula, and similarly you can write it down for YCOM and ZCOM. Now let me explain some of the important points to you. We have already discussed center of mass of two bodies. This is R1, and please remember center of mass will be nearer to the heavier body. Center of mass will always be nearer to the heavier object, right? So this is continuous mass distribution for center of mass for continuous mass case, and these are some of the formulas that you must remember, right? So for rod it is absolutely easy, L by 2. In rod we have got no problem, we have also solved 1 or 2 questions of rod. For semicircular ring, please remember it is 2r by pi. For semicircular disc it is 4r by 3 pi. For hollow sphere it is r by 2. Right? For solid sphere it is 3r by 8. For solid cone it is h by 4 from the bottom. This is very important, it is from the bottom. For triangular plate it is 2h by 3. For hollow cone it is h by 3. So for cone, please remember whether they are going to talk about solid or hollow. This is very important, right? Now let me give you 1 or 2 questions related with this very quickly. See, the first problem based on this concept is, we are going to solve, let's suppose a question like this. Straight away motion of combined bodies. Clear? Motion of combined bodies. Let's understand this problem. This is a nice question. In this they are saying a uniform circular wire, semicircular wire, of mass 2 kg and radius 2 meter is placed above the uniform semicircular disc. This is very important, semicircular disc of mass 10 kg and radius 1 meter. This means that if we have got a ring over here, this is a ring, and this is a disc. So if you have got a ring, just now I have told you that the center of mass of a ring will be at 2r by pi. So this is going to be the center of mass of ring, and this will be, this distance y will be 2 into r by pi. Please remember I am using formula of ring as 2r by pi. For disc, just now we have written it is 4r by 3 pi. So for disc, the center of mass will be 4r, r is 1 divided by 3 pi. Clear? So when we are going to write down the y-COM, now please understand x-COM will be 0 because x-axis is the axis of symmetry. I am sorry, because y-axis is the axis of symmetry. Y-axis is axis of symmetry. This implies that x-COM will be 0. If let's suppose x-axis is axis of symmetry, then y-COM is 0. If let's suppose both of the axes are axis of symmetry, that means center of mass is at origin. That means we have got a symmetrical object, right? So to solve this particular problem, now it is very easy. We are going to simply use the concept of combined bodies M1y1 plus M2y2 divided by M1 plus M2, my dear friends. M1 plus M2. So mass of this ring is 2 kg. This was 4 by pi plus mass of this is 10 kg, and distance is, please remember I was talking about this as distance, but I am going to write down the coordinates. So I am going to write it down with a negative sign, minus 4 by 3 pi whole divided by mass, that is 12 kg. Hopefully this makes complete sense. So if you are going to kindly see, this is 8 and this is minus 40, right? Or what you can do is you can cancel all of these things with 4, right? So this will get cancelled out, this will get cancelled out, and this will become 3. Hopefully this makes sense. I can write down 3 and I can write down 3. So this will become 6. This is minus 10. So this will become minus 4 upon 3 pi and 3, that is minus 9 pi. So minus 4 by 9 pi. Minus 4 by 9 pi, that means D option is correct. Is it clear? Any more doubt? Be quick. Let me know in the chat box. Come on. Everything is sorted? Quickly, let me know in the chat box, my dear friends. Motion of combined bodies, right? You don't have to practice derivations for these things, but derivation can come, right? So I'm going to explain one derivation also. Hopefully this makes complete sense. Moving on to the next one. We are going to talk about cavity problems in a while, but let's also discuss this question. See, usually what happens, let me explain the derivation for a rod. I'll be a little quick, so don't worry, I'm not going to, I know that you guys already know this derivation, but I'm just explaining the concept. What we do is, we actually, we go at a distance of x, we mark a length element which has got mass dm and length dx, infinitely small. And then we say that because it is a uniform distribution, please understand, if it is a uniform distribution, it means that this is going to be constant, lambda will be constant. So either I can write it as m by l, or I can also write it as dm by dx. Basically what I'm trying to do is, I'm going to write down, instead of dm, I'm going to write it down as lambda times dx. Lambda times dx. Clear? And then I'm going to simply say that x COM will be x into dm, integral of this and integration of dm. So x, instead of dm, I can write down lambda times dx, and divided by integration of dm will be m, and integration of this will be from 0 to L, and when you are going to do each and everything, you will get L by 2. No doubt about it. But many times, obviously in your NEET exam, they are not going to ask you to derive this, right? But what they can do is, if let's suppose this is not uniform, if the case is of not uniform distribution, then you will have to derive it. There is no other option. There is also one more option, that you can use options, you can use your multiple choice options to find the correct answer. Let me tell you how. Let's suppose we have got a question like this. Let's suppose we have got a question like this, in which they are saying that lambda is like this, all right? So this is absolutely not uniform, this is a non-uniform distribution case, all right? So again, we are going to do the same thing. We are going to say that x COM will be integration of x times dm divided by integration of dm. So instead of dm, what we are going to write it, dm by dx is equals to lambda, and instead of lambda we can write 1 plus b x square. So instead of dm, you are going to write a 1 plus b x square times dx. This is your dm. And now when you are going to substitute it over here, you are going to get x times 1 plus b x square times dx whole divided by a into 1 plus b x square, and integrated from 0 to L, and then you are going to get your answer. And then you are going to get your answer. Is it clear? Right? Everything's fine? Quickly let me know in the chat box. Hopefully you guys can integrate this. You just have to use power rule, that's it, nothing else, right? So integrate this, my dear friends, and you will get to your answer. And now let's move on to one of the another topic that is related with cavities, right? Let's solve one question from cavity. And my dear friends, let's solve a question like this. This is a case for a question from cavity based. Question from cavity based basically means, now please understand, let me explain one question to you, then I'll also give you one problem from my side. For pole, a sphere of radius r has a smaller sphere of radius r by 2 and it is removed from it as shown in the figure. So we are removing this smaller sphere. Determine the y coordinate of center of mass of the remaining portion of the sphere. Right? We have to find out the center of mass of the remaining portion of the sphere. So the concept that we use in this case is of negative mass density. Please understand. We are going to say that because they are talking about sphere, let's say the density of this sphere is plus rho. So density of this sphere will automatically become negative times of rho. It is a hypothetical concept. And density is basically, they themselves have said that can I assume mass as m? So mass is m and divided by, that means I can write down density as mass divided by volume 4 by 3 pi r cube. Also I can write down mass as density into 4 by 3 pi r cube. That means this m dash will become negative times of density times 4 by 3, and now please understand the radius is actually r by 2. Radius is r by 2. So 4 by 3 pi r cube. So that means r cube divided by 8. Now rho 4 by 3 pi r cube, rho 4 by 3 pi r cube is simply m. So this will become m divided by 8. Here this will become m divided by 8. How do I know this? Because I can't see pi and anything else in my answer, right? So now I'm going to say that, okay, center of mass of this is over here. Kindly see, center of mass of this negative mass sphere is over here, and center of mass of the complete sphere is over here, right? So, and by the way, this is 0 comma r2. So now we are going to say that YCOM will be m into 0 plus minus m by 8 times r by 2 whole divided by m minus m by 8. So this will become 8, this will become 8, this 8 will get cancelled out, right? M will get cancelled out, and you will get minus, my dear friends, you are going to get minus, this is r, and this will become minus r by 14. Minus r by 14. Clear? Everything is sorted. Quickly write down in the chat box, this is going to become minus r by 14. Let me know in the chat box. Done? The concept is whenever you are going to have a question of cavity, we are going to assume two things. Please see, whenever you are going to have a concept, a question on cavity, the concept is something like this. Cavity questions. Let's suppose you have got a sphere or you have got a sphere or disk, right? Any object. See, if it is a disk, then I'm going to talk about sigma. If it is a sphere, I'm going to talk about rho. And let's say they are saying that we have removed another sphere of radius r by 2 from this, something like this. This is the cavity. So the idea behind is what you need to do is you need to assume them as separate objects. So this is another object whose center of mass is at this point, at 0 comma 0, right? And then you have to assume this as another object, okay, and this is the cavity, and whose center of mass will be somewhere over here. And then you will have to apply your normal, this is m1 and this is m2, and then normal formula of discrete mass particles, right? So this is the primary concept, and this is how you can solve questions of this topic. Now let me give you another problem. You guys solve this question. All right, you guys solve this question. I'm going to start poll for this. 90 seconds. Let's start. Come on. Similar type of a question. You have got a square plate. So use sigma, right? You have got a square plate and we are cutting out a disc from it. Come on, be quick, my dear friends. Be quick. Let's solve this question. And write down in the chat box if everything's clear till here. Quickly. Write down in the chat box if everything's clear till this point. After this, we are going to talk about motion of center of mass also. Come on, be quick. Solve this particular problem. See, again in this question, my dear friends, center of mass is at this point of this rectangular plate, square plate, right? And let's say that mass density is plus sigma. Mass density is plus sigma. So capital M can be written as sigma multiplied by L square. Sigma multiplied by L square, dosto. Is that clear? This means that this will have a negative mass density. This will have a negative mass density, and mass of this will become minus sigma times pi into r square. And my dear friends, the radius will become, they are saying that radius is L by 4. Radius is L by 4. So pi r square, so L square by 16. Now sigma into L square can be written as m, so this will become minus pi m upon 16. Minus pi m upon 16. Instead of sigma into L square, I have written capital M, so minus sigma m divided by 16. Now please understand, center of mass of this disc is over here. Center of mass of this square plate is over here. This is 0, 0. Coordinates of this are 0, L by 4. So when you are going to talk about YCOM, first you are going to write capital M times 0. Then you are going to write minus, I am writing minus because of this M dash, minus pi M by 16 multiplied by this distance, that is L by 4, whole divided by total mass. Now when you are going to write down the total mass, write it down something like this: m minus pi m by 16. All right, write something like this. Hopefully this makes sense. Now after this, let's see if we are going to get to our answer. This will become 16, this will become 16. One of the 16 will get cancelled out. M will get cancelled out, right? So you are going to get negative times of pi into L divided by 4 times of 16 minus pi. 4 times of 16 minus pi. Although this answer is absolutely correct, but I believe that we'll have to manipulate our answer a little bit. That's it. I don't think there is any other trouble in this. I can't find any other trouble, right? So my dear friends, we need to just this is going to become minus pi L divided by 64 minus 4 pi, right? I think this answer is absolutely correct. This is absolutely correct. No doubt about it. This is correct. You tell me if you have any other doubt in this. You tell me if you have any other doubt in this, my dear friends. According to me, this is absolutely correct. pi L divided by 4 times of 16 minus pi. This is absolutely correct. There might be some chance that we can change this answer by a bit. There may be some case. Is there any such cases? Or maybe there's maybe there's one pi missing from this option. Maybe there's one pi missing from this option, I believe, my dear friends. If there is one pi over here, so this will become pi L, and this minus sign can be written as 4 pi. Is that correct? Hopefully you guys are understanding what I'm saying. So this will become pi L divided by, this will become 4 pi minus 64. I think something like this will happen, right? Or if you want to have a minus sign over there, so you're going to write minus sign pi L divided by 64 minus 4 pi. Or L is getting cancelled out. I think L is not getting cancelled out. So this is correct answer, right? Clear? Is there any doubt? I think option C, I'm going to select option C as the correct answer because I have started the poll. Hopefully the concept is absolutely clear. Concept is absolutely clear to all of you, right? Now let's move on to next questions. Now we have solved questions of discrete, we have questions of combined bodies, we have solved 2 questions of cavity problem. Let's solve this question. Come on, be quick. A solid sphere of radius r has a spherical capacity of half of its radius touching internally the surface. All right. So let's suppose you have got another sphere, right? You have got another sphere and we have got a sphere touching it internally, and this is actually a cavity. Clear? And then we have to find out the shift in center of mass. We have to find out the shift in center of mass. So this is m, and this is minus m, and this is going to be r by 2 comma 0. This is r by 2 comma 0, and this is, let's suppose this is m dash. I think you guys can solve this particular question, my dear friends. I can write down m as rho into 4 by 3 pi r cube, and I can write down m as minus rho 4 by 3 pi into r cube by 8 because radius becomes half. And this is exactly the similar problem, right? So this is going to become, I think, 14 or 7, right? 14 or 7 is going to be the correct answer. So rho 4 by 3 pi r cube is nothing but m. So this will become minus m by 8. Now you guys can find out the XCOM. XCOM will be 0 times m plus m dash times r by 2 whole divided by m minus m by 8. So this will become 8, this will become 8, one of the 8 can get cancelled out, m can get cancelled out. You are going to get minus r by, this is 2 and this is 7, so that is 14. 14 is the correct answer. 14 is the correct answer, right? B option is absolutely correct. Clear? Now let me tell you one more question. Now please see, you don't always have to integrate it, right? You don't always have to integrate it. Like for example, let's see this question. In this problem, we have got a thin rectangular plate. In this problem, we have got a thin rectangular plate. Got it? Come on, be quick. Let me know in the chat box. Everybody is here. Come on. See, we have got a thin rectangular plate and the sigma varies something like this, right? Sigma varies something like this. That means sigma only changes, sigma depends only upon x and it is independent of y. It is independent of y. If it is independent of y, that means mass is uniformly distributed. Mass is uniform with respect to y-axis. I mean, I'm so sorry, not with respect to y-axis, but mass is uniform along y-axis. Along y-axis, right? This means that let's suppose that this structure, this rectangular plate was absolutely uniform. Its sigma was uniform, its sigma was constant. In that case, I would have said that center of mass would have been at this point. Center of mass would have been at this point, that is a by 2 comma b by 2. So initially this point is a by 2 comma b by 2. But now because sigma is directly dependent on x, which means that as you are moving in x axis, mass density is increasing. So but mass density is not increasing along y direction, which means that new center of mass will be somewhere over here. This is going to be your new center of mass. That means y coordinate will not change, but x coordinate will change. So this will become b by 2 comma, now this value must be slightly greater than a by 2, right? Slightly greater than a by 2. So this can't be the answer because this is a by 2 comma b by 2. This can't be the answer because this is less than a by 2. So either it, and this can't be the answer because this is 2b by 3. So correct answer is option A. So you don't have to integrate it. That's what I'm trying to say, right? You don't have to integrate. You can use this concept, and this is absolutely valid. If examiner is going to give you a question like this, they might give this question keeping this thing in mind, that you must not solve it. You can save some time. Is everything clear? Quickly write down in the chat box. Be quick. Now we are starting velocity of center of mass. Now we are starting, sorry, not velocity but motion of center of mass. Motion of center of mass, another big section of this chapter. Another big section of this chapter, motion of center of mass. Now we are going to talk about motion of center of mass. Now please see, we already know that how to write down RCOM, right? RCOM will be simply written by M1 R1 plus M2 R2 and so on, plus Mn Rn plus Mn Rn, and divided by summation of all the masses. So let me simply write them as capital M, right? Let's suppose we are differentiating this equation. But before differentiating it, please understand what do we really mean by differentiating it. We mean to say that let's suppose these particles starts to move. We have got M1 over here, we have got M2 over here, we have got M3 over here, we have got Mn over here, and so on. And suddenly they all starts to, not all, but some of them might start to move. Now this is very, very important and conceptual, so you must pay attention. Alright, so this is R1 vector, this is R2 vector, this is R3 vector, this is Rn vector. Now when you are going to differentiate all of these things, or let's suppose you have got center of mass at somewhere at this point. This is your center of mass and this is RCOM. This is RCOM. So when you are going to differentiate it, basically it means that you are trying to find out the velocity of center of mass. And you can find it out by writing dRCOM by dt. Or you can write M1 into dR1 by dt, M2 into dR2 by dt, and so on. Mn into dRn by dt. Now I've got one question for all of you. This is why I was saying that all of these things are very conceptual. Let's suppose I'm giving you one condition. I am giving you one condition in which I'm saying, let's say VCOM is 0. if VCOM is 0, then what you have to say about then this is, by the way, V1, this is V2 and so on. This is V1 vector, this is V2 vector. What you have to say about V1 and V2? Let's suppose I am saying that VCOM is 0. Let's suppose I am saying that VCOM is 0. Then what you have to say about this? Basically means that center of mass is at rest. Center of mass is at rest. This basically means center of mass is at rest. What you can say about V1, V2, V3? Are all particles are at rest? Say yes or no. I am asking if velocity of center of mass is 0, which basically means that center of mass is at rest. So does this means that all the particles are at rest? Be quick. Does this means all the particles are at rest? Quickly let me know in the chat box. Say yes or no. If velocity of center of mass is 0, this means that center of mass is at rest. So does this mean that all the particles are at rest? Some of you are saying yes. Well, answer is no. Answer is no. Then particles may or may not be at rest. May or may not be at rest. Please understand, this is the vector sum of VCOM can be actually written as M1 into V1 plus M2 into V2 and so on, and divided by total mass. So this is vector sum, my dear friends. So vector sum can come 0 even when individual vectors are not 0. Even when individual vectors are not 0. So there is no necessary condition. It may be 0, it may not be 0. So do not remember that okay, always they are going to be non-zero. That's also wrong. I mean, system can be at rest. Are you getting it what I'm trying to say? For example, let's suppose I'm giving you one example. We have got two particles, M1 and M2, and let's say this is 1 kilogram and this is 2 kilogram, and this is moving in this direction with 1 meter per second of velocity. This is moving in this direction with 2 meter per second of velocity. Got it? Both of them are moving, but when you are going to write down the VCOM for this one, you are going to write it down something like this. You are going to write 1 kg multiplied by -2 plus 2 kg multiplied by +1 divided by total mass, that is 3 kg. So -2 plus 2 is 0. They are moving but in opposite direction. Is it clear? Sorted, my dear friends? Or they can be at rest also. If let's suppose both of the particles are at rest, so center of mass will also remain at rest. Velocity, motion of center of mass is a very, very important topic. Let me tell you, please understand this very carefully. Right? Now, after this, my dear friends, let's move ahead and then let's talk about acceleration of center of mass. Let's talk about acceleration of center of mass. Acceleration of center of mass can be written as dVCOM by dt. It can be written as dVCOM by dt, or we can write it down as m1 dV1 by dt, vector sign, vector sign of course on velocity, plus m2 into dV2 by dt and so on, mn dVn by dt. And this is going to be, let me simply write down as capital M. Again, please note that if V1, V2, V3 are changing, that doesn't mean that always acceleration of center of mass will be non-zero. Please understand what I'm trying to say. Let me reverse this definition. If let's suppose if acceleration of center of mass is 0, this does not mean that A1, A2, A3 may or may not be 0. May or may not be 0. May not be 0. But now we are going to talk about a very important concept. Understand. Let's suppose we are talking about an example in which center of mass, in which center of mass is either at rest, or in motion. So either it is at rest or it is in motion, but motion is also uniform motion. And then we are saying, please see, then we are saying that it is at rest, and if net external force on the entire system is 0, then we'll say then center of mass will remain at rest. It will remain at rest. Please understand that we are going to consider the entire system as one single particle, and that single particle will be called as center of mass. So if initially center of mass is at rest, now you are going to see many such examples, especially those Planck, Boy and all of those kinds of things, right? So let's suppose you have got a Boy and you have got a Planck. Let's suppose mass of Boy is small m, mass of Planck is capital M, length of this Planck is capital L. And Boy is moving on Planck, and Planck is on ground, on a smooth ground. So this is smooth. Obviously, if Boy is able to walk on the Planck must have friction, but we don't have to care about that, right? We don't have to care about that. We know how friction works. Friction of Boy will act in forward direction. Friction on Planck will act in backward direction. That's how this thing works. But when I'm going to talk about this entire system, I'm going to say that before the boy starts to walk, center of mass of this system was at rest. So initially center of mass was at rest for this system. And then I'm saying that the net force on this entire system, net external force, is also 0. There are no net forces. So if there are no net forces, it means that if center of mass was initially at rest, it will always remain at rest. So this is the basic principle behind solving questions like this, right? So note these things. Let's suppose if it is moving with uniform motion, and somebody says that net external force acting on the system is 0. So we basically say that let's suppose we have got a system M1, M2, M3, M4, Mn, M1, M2, M3, M4, Mn, and let's suppose a total force F is acting on it. So instead of all of these things, we simply say ki let's suppose we have got a center of mass and we are applying a force on it. So if let's suppose this net force is 0, and if let's suppose initially center of mass was moving with uniform motion, so it will keep on moving. Center of mass will keep on moving with same velocity. Now this is the case when we talk about explosions. Do you remember? This is the case when we talk about explosions. Let's suppose a particle is moving like this. This is the normal trajectory of the particle, but at a particular point, explosion happens, and let's suppose the particles breaks into 1:3 ratio. One of the particle goes over here, another particle goes over here, but the center of mass will remain in the same path. Center of mass will remain in the same path. That is what the concept is, right? Are you getting it? Center of mass will remain at the same mass, same part. So let's suppose the total mass was 4m. So this is, let's suppose, m. This is, let's suppose, 3m, or I'm sorry, let's suppose this is 3m and this is m, right? So center of mass of these two particles will remain at this particular point, which is actually the initial point on the trajectory, right? Clear? Everything is sorted, right? And now just to explain, just to finally explain this thing to you, if net force is 0, net external force is 0, please remember that dp by dt is 0. And if dp by dt is 0, this basically means that momentum of the system will remain constant. And this is what do we call as conservation of linear momentum, right? Now let's solve some problems. Hopefully this much theory is clear. I have explained each and every concept. Please remember that individual velocities, individual acceleration, individual displacement may or may not change due to internal reasons, but when you are going to talk about center of mass, you have to understand that it is basically the vector sum of all of these things, right? So it may be 0, it may not be 0, it depends upon the situation. Come on, my dear friends. Now let's move on to our next topic. Let's solve this question. Not topic, let's solve questions now. Okay, let's solve some questions now. So this is our next question, the velocity of the center of mass. We have to find out the velocity. Just see, I'm going to explain this question to you. You have got 2 meter per second, so this will be 2 meter per second cos theta. This will be 2 cos 30. That means 2 into root 3 by 2. So this is your Vx. This is your Vx. And this is your Vy. So this will be 2 into sine 30, that is, and obviously this will be in minus j cap. So you have to understand all of these things also. So when you are going to talk about V2, you are going to write something like this. V2 will be root 3 I cap minus j cap meter per second. Minus j cap meter per second. And V1 is 2 meter per second I cap. Clear? So center of mass velocity will be m1 into 2, that means 1 into 2, so that means 2 I cap meter per second. Then m2 into V2. So V2, my dear friends, first we are going to write down root 3 I cap and minus j cap whole divided by total mass is 3. Hopefully this is all clear to you. So this will become 2 plus 2 root 3 divided by 3 I cap minus 2 by 3, and this is j cap, minus 2 by 3 and this is j cap. So that means option B. Obviously first few problems are always easy. Now let's move to some different questions, right? Let's solve this question, my dear friends. Be quick. Two particles of equal mass are projected simultaneously with speeds 20 meter per second and 10 root 3 meter per second as shown in the figure. Find the maximum height reached by the center of mass. Reached by the center of mass. We are talking about center of mass. Okay, let's start. 90 seconds. Let's begin. Be quick. I want answers in this. In the meantime, I'll help you guys. This is 20 meter per second, right? So I'm not concerned with the x direction velocities. So I'm going to write down v1, obviously y. So that is 20 into sine 30, that is 10 meter per second. v2 y will be 10 root 3 times sine 60, that is 15 meter per second. This means that velocity of center of mass will be equal masses. So m1 v1 plus m2 v2 divided by 2m. So you are going to get 25 divided by 2. 10 root 3 into root 3 by 2. So root 3, 3. And yes, I think everything's clear, right? Now when they are talking about maximum height, please remember this basically means that, kindly see, this basically means now the diagram has changed. We have got a mass 2m and we are throwing it with a velocity of 25 by 2 meter per second. So you have to find out the maximum height. So 0 square is equals to v square, sorry, u square minus 2as. Kindly solve this question. So h max will be square of 25 divided by 4 times 2 into 10, right? So this will become 5, this will become 2. So this will become, my dear friends, 125 divided by 16. 125 divided by 16, option C is correct. Right? Clear? Any more doubts? Option C is fine. Good, very good. Harshita, Dr. Sarfaraz, Tejaswini. All right, whoever this is, and Yash. Come on, be quick. Let me know in the chat box. Clear? Everything sorted? Be quick. Let me know. My dear friends, do you have any other doubt? Done? Can we move on to the next one? Here? All right. Let's move. Let's solve this question. Be quick. In this question again, see, they are saying we have got two particles of masses 2 kg and 3 kg, and these are moving on a horizontal plane as shown in the figure. The first mass 2 kg moves with a speed of 10 meter per second, making an fine. Whatever they have given, they are simply writing same thing over there, right? Fine. So in these types of problem, what you can do is you can simply write down these in the vector form. So this is, let's say this is your particle 1, right? Let's say this is your particle 1. So this will be v1 in along x-axis. So this will be tan times 3 by 5. So this will become 2. So this will become 6 meter per second. This will become vy. So this will become 10 into sine 37. This is 4 by 5. This is 8 meter per second. And this is sine 37. This is 3 by 5. This is 6 meter per second, right? Now this means that I can write down V1 in vector form something like this. This is 8 I cap plus 6 J cap in meter per second. Similarly, this one will be V2 along x-axis, and this is going to be 20 into cos 53. Cos 53 is 3 by 5, right? So this will be 4 and this is going to be 12. and this is going to be V2 in along y-axis. So this is going to be 20 into, this is going to be 4 by 5. This will become 4 and this is going to be 16 meter per second. So I have already written V1 for you. Now V2 will be in vector form, it will be minus 12 I cap and plus 16 J cap, and this will be in meter per second. This will be in meter per second, right? This will be in meter per second. Clear? Now for velocity of center of mass, although I need some space, but fine, I'll try to adjust it over here. So 2 into 8, right? 2 into this 8 I cap plus 6 J cap plus 3 into this, that is minus 12 I cap plus 16 J cap whole divided by total mass, that is 5. Total mass, that is 5. So we are going to get 16 I cap plus 12 J cap minus 36 I cap plus 48 J cap whole divided by 5. Hopefully answer. Okay, we'll get to the answer. So my dear friend, this will become minus 20 I cap divided by 5, and then we'll have plus, this will become 60 by 5 J cap. So this is 4 and this is 12. So minus 4 and plus 12, minus 4 and plus 12. So minus 4 and plus 12. So either it's going to be A or it's going to be B. Whereas when kinetic energy is concerned, just a second, let me also explain kinetic energy to you. See, so finally velocity of center of mass is coming out to be minus 5 I cap plus 12 J cap, and this is in meter per second. This is in meter per second. Clear? Right? This is in meter per second. All right. Sorry, minus 4. Sorry, by mistake I have written minus 5. This is minus 4. This is minus 4. So mod of VCOM will be under root of 4 square plus 144. Right? This is, but okay, fine, we don't have any problem with that, whatever that is. I mean, this is going to become 10 and 0, and this will become 5, 6. So this will become 160, I believe, right? 160. So kinetic energy will become, kinetic energy of center of mass will become 1 upon 2. Total mass is 5 kg, and because I have to do V square, so this is, right, so this will become 80 and this will become 400 joules. So 400 joules is the correct answer. Option A. Option A. Is it clear? Quickly write down in the chat box. Be quick. Done. You guys will be able to solve questions like these. Any more doubt? Any more doubt, my dear friends? Is everything fine? Quickly let me know in the chat box. Very good, Yash. Good, Ananya. All right. All right. All right. All right. Great. This is also a nice problem. Right. I only bring nice problems. Good. Good, 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 good. Find the final common velocities of the system. ठीक है. So we have to find out the final common velocity. Acha, hopefully you don't have any doubt in simple Planck problem. I have actually skipped that. This is another type of a Planck problem in which we have got coefficient of friction and it is 0.4. It is 0.4. Okay, this is 0.4. So you have to find out the common velocity of the system as shown in the figure at t equals to 0. So please understand, whenever they say something like this and t equals to 0, that means we need to find out the velocity of center of mass at this point. So at t equals to 0, velocity of center of mass is m1 4 kg into 0, because it is not moving at t equals to 0, 1 into 10 whole divided by 1 plus 4, that is 5, right? So this will become 0, this is 2, so answer is 2 meter per second. Answer is 2 meter per second. So either the answer is going to be option B or option D. Either option B or option D. Now let's talk about the B part. In B part, they are saying find the displacement of the center of mass when slipping between the block stops. Slipping between the blocks basically means, this basically means when they'll move with same velocity. When they'll move with same velocity, at that point slipping will stop. The point when they'll move with same velocity, at that point slipping will stop. So right now this is moving with 10 meter per second, right? And it will keep on moving with 10 meter per second, but hold on, not keep on moving with 10 meter per second. Friction is there. So my dear friends, because this block is moving in forward direction with 10 meter per second, there will be a friction force that will act on this, and there will be a friction force on this plank in forward direction. Right? If you are going to ask me, sir, what is this friction force? I am going to write friction force is nothing but mu times normal reaction. Value of mu is 0.4 and normal reaction is 10 kg. So that means a 4 Newton of force is acting on the plank and 4 Newton of force is acting on the block, right? So after what time will the slipping stop? Slipping stop basically means that they'll move with same velocity. And if they'll move with same velocity, then let me tell you one thing. Let me tell you one thing, my dear friends. You're not going to find these questions anywhere, right? At the very start, I have told you that I have brought some really good examples for you. Right now, I think we have almost 2 hours down this class and we have solved various such problems. So all the students who have just now joined after my class is finished, watch this entire lecture. It is filled with really good problems. Now see, let me first talk about the block and let me write down the velocity for it. So V equals to U minus AT. So my dear friends, acceleration of block will become total force divided by total mass, that is 4 meter per second square, and this will be a retarding force, right? And acceleration will be retardation. So 10 minus 4 into T. So this is for block. And now when we are going to talk about Planck, we are going to say for Planck, acceleration of Planck will be total force divided by total mass, that means 1 meter per second square. And then we are going to say V equals to U plus A into T. Now velocity must be same. So velocity must be same basically means that T should be equals to 10 minus 4T. That means after 5 seconds, after 2 seconds slipping will stop. After 2 seconds slipping will stop. After 2 seconds slipping will stop. And if after 2 seconds slipping stops and center of mass is moving with 2 meter per second, so distance traveled by center of mass will be simply 2 meter per second multiplied by 2 seconds, that is 4 meter. So answer is option D. Now you are going to say, sir, hold on a minute. You are talking about acceleration in this block, you are talking about acceleration in this plank, but when you are talking about distance, you are simply writing speed is equals to distance upon time. Why? Please remember that on the entire system, net force is 0. Friction force is acting in forward direction 4 Newton, friction force is acting in backward direction 4 Newton. Net force is 0. If net force is 0, that means that I am going to simply say one thing, that center of mass will keep on moving with constant velocity, and that is for 2 meter per second. Is it clear? Quickly let me know in the chat box. Be quick. Sorted? Any more doubt? Done? Can we move on to the next question now? Can we move on to the next question? Clear, 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 clear. Let's move on to the next one. This was a nice question. Two particles of equal mass m have respective initial velocities u I cap and u. Acha, now we are going to, before collision, hold on. Let me tell you if you have got more questions on this topic. Else I'll start collision. I'll first explain collision. Just like this, I've explained the entire theory of motion of center of mass. Then we have solved some nice problems. Now let me also explain. Now let's also talk about collision, right? And then we are going to solve some questions of collision. Clear? All right. Achha, before moving on to the collision, I've got some more important points for you. Right? First of all, remember the formula of center of mass for a circular arc. And please remember it like this, that let's suppose if you have got a circular arc and angle is 2 theta, then from the center point, it is at the distance of, this distance will be r sine theta by theta, and angle is 2 theta. I've already explained you the concept of cavity, so I'm not going to explain it again, but please also remember the formula of circular plate. Derivations are not important, but you need to know how to derive it for non-uniform distribution case. For all the uniform distribution case, simply remember the formula, right? And this is for circular plate. Again, in this also same thing will happen. Whenever you are going to draw the angle from here, this angle will be, in this also the angle will be 2 theta. Angle is going to be 2 theta, my dear friends, right? Hopefully this makes complete sense. Now come over here. I have explained each and everything. You are also going to get all of these notes, right, on our on WhatsApp channel of PW NEET English. So you can join that as well. The link is in the description box. Motion of center of mass already explained. If net force is 0, this is important. If net force is 0, that basically means that net acceleration is 0. That means that net acceleration on center of mass is 0. Confirm, no doubt about it. And if this is 0, that means confirm velocity of center of mass is constant. But we cannot say anything about A1, A2, A3, V1, V2, V3. A1, A2, A3 may or may not be 0, and V1, V2, V3 may or may not be constant, right? May or may not be constant. Clear? Some examples are this. I have also explained the example. My dear friends, please remember impulse. Impulse is very important. It is one of important topic and favorite topics for examiners. Impulse is change in linear momentum. It is a force which acts for a very short interval of time, right? So now moving on, let's talk about coefficient of restitution and collision. See, coefficient of restitution is a very important formula. Please remember it. Coefficient of restitution can be also written as impulse of reformation divided by impulse of deformation. Or usually we remember the formula as velocity of separation of point of contact divided by velocity of approach of point of contact. So let's suppose that if collision was about to take place between these two bodies, for that of course u1 will have to be greater than u2. In that case, coefficient of restitution will be written as velocity of separation divided by velocity of approach. So velocity of approach will be u1 minus u2. For velocity of separation will be v2 minus v1, right? If let's suppose this is the case, my dear friends, please understand this case, this is very important. If a ball is dropped and it is going to collide the ground, it will have a collision with the ground, so it will collide with a velocity of root 2 gh. Got it? So velocity of approach is root 2 gh. At this particular point, it will strike the ground with a velocity of root 2 gh, and it will move up with a velocity of, let's suppose it goes up to a height of h1 only. It is being dropped from h height and it goes up to a height of h1 only. That means velocity of separation is root 2 gh1. What is the other body? The other body is ground, and ground has velocity 0, right? Clear? And then we are going to talk about line of impact. Line of impact is basically the common normal to the surfaces in contact during impact. So this is the common normal. This is the common normal, my dear friends. This is the common normal. This is known as line of impact. The line along which the particles are moving, the bodies are moving, that is known as line of motion. So this is line of motion of A, this is line of motion of B. If let's suppose any one particle has any component of velocity other than the direction of line of impact, that means that we are going to have an oblique collision. Else, this is case of head-on collision. This is also oblique collision. This is line of motion. This is line of impact, right? This is line of motion. This is line of impact. Now, let me also explain one concept to you. Let's suppose that a ball is striking at this point. It is coming in this direction. That means it has velocity. Let's suppose it has velocity u. It has velocity u, something like this, right? Clear? And let's say this angle is theta. And also, let's suppose coefficient of restitution is E. If coefficient of restitution is E, this means that when the particle will move after collision, this angle may or may not be theta. Please understand, this angle may or may not be theta. It will depend upon the value of E, right? But one thing is certain, when this ball will reach at this point, the common normal will be something like this. The common normal will be something like this. This is going to be the common normal, and this is going to be the line of impact. This is going to be the line of impact. This means that only velocities which are along this line will get changed, and velocities which are not along this line will not change. This basically means, my dear friends, you have got u. We can write down ux like this. You can write down uy like this. And if this angle is theta, then this angle is theta, then this is u sine theta. If this angle is theta, I'm so sorry. Yeah, absolutely, everything is clear, right? Everything should be clear, my dear friends. Right. If this angle is theta, then this angle is 90 minus theta. Right? If this angle is 90 minus theta, this angle is 90, this angle will be theta. So this will be u sine theta, this will be u cos theta. So I am saying that after collision, what's going to happen is that this velocity will not change. This will remain same, and that is u sine theta. And this velocity will change. And when you are going to talk about this velocity, let me write down this as Vy dash. Let me write down this as Vy dash. Now, coefficient of restitution is equals to velocity of separation. So, velocity of separation is Vy dash divided by velocity of approach is u cos theta. So, Vy dash will be E into u cos theta. E into u cos theta. So, this is going to be E into u cos theta. E into u cos theta, right? E into u cos theta. And if now let's suppose you want me to say ki sir what is this angle? So understand this angle is going to be same as this angle. Let's say this angle is phi. So tan phi will become my dear friends, this is tan phi and this is perpendicular, right? So obviously it will be u sin theta divided by E u cos theta. Is it clear? So that means tan theta will be equals to E into tan phi. E into tan phi. Please check angles once again. My dear friends, I am saying this angle is phi, right? If let's suppose E is equals to 1. Now please see. In elastic collision, that means when energy is conserved, in that case E is equals to 1. And if E is equals to 1, tan theta is equals to tan phi. In that case, tan theta is equals to tan phi, right? Clear? Hopefully now this concept is clear to all of you. Let me know. When we are going to talk about the types of collision, we are going to categorize the collision on the basis of first line of impact. Second, we are going to discuss about the conservation energy part, right? So first let's discuss the line of impact. So for line of impact, we have got two types of collision. One is head-on collision, another one is oblique collision. I have already defined this to you, right? You can also read the definition. On the basis of energy, please remember we have got elastic collision. See, no matter what type of collision you have got, conservation of linear momentum is always applicable, is always valid, right? Conservation of linear momentum is always valid, but in elastic collision, in the first one, along with conservation of linear momentum, you can also apply conservation of mechanical energy. So you have got three things. You have got conservation of linear momentum, conservation of mechanical energy, and then you have got coefficient of restitution, right? So if let's suppose you have got elastic collision, then coefficient of restitution is 1. In case of other collisions like inelastic collisions, conservation of mechanical energy is not valid because we don't have an account of the deformation potential energy, right? So conservation of mechanical energy is not valid. Still we can apply conservation of linear momentum, and obviously we can apply the value of E. If you are going to talk about perfectly inelastic collision, in this case the bodies stick together. The bodies stick together after collision. The bodies stick together after collision. Is it clear? Right? Hopefully everything is sorted, my dear friends. Now let's move on to some questions on this. Let's move. By the way, I think you guys can solve this question very easily, right? You guys can solve this particular problem. In this, basically the man is traveling towards this side, so you have to find out the displacement of center of mass, right? I think you guys can solve this question. Please remember that when the man is going to, when man or boy, whatever this is, let's suppose the plank moves in x direction backwards, right? So this displacement is x. So when man reaches at this point, actually man only travels L minus x, and Planck travels x displacement, right? So you have got m, and by the way, okay, fine. So you can cancel out m, and you have got L minus x is equals to 2x. That means x will be equals to L by 3. L by 3 opposite to the man. So that is why I was saying ki you can easily do these types of problems, right? Hopefully this is all clear to you. This is displacement method. The concept is same. Why we are doing this? The concept is, my dear friends, if anyone has any doubt in this, we are basically saying that m1 x1 plus m2 x2 and so on must be equals to 0, must be equals to 0 for a simple reason that center of mass was initially at rest. Center of mass was initially at rest. Center of mass was initially at rest, right? Clear? Now let's solve this question. Be quick. Let's solve this problem, my dear friends. Two particles of equal mass have respective initial velocities u I cap, and second one is, acha, theek hai, have initial. So this is u1 and that is u2. They collide completely inelastically. If they collide completely inelastically, that means that coefficient of restitution is 0 and they are going to stick together. They are going to stick together, right? All right. So in these types of cases, first of all, apply conservation of linear momentum. In these types of cases, first of all, apply conservation of linear momentum. So for conservation of linear momentum, my dear friends, initial velocities are masses, two particles of equal mass. So m into u I cap, m into u I cap plus m into u by 2, u by 2, and then you have got I cap plus j cap and equals to, because they are sticking together, 2m into v velocity vector, common velocity vector, right? Common velocity vector. So I can cancel out m, I can cancel out m, and then my friends, if you will allow me, I can write this thing as, this will become actually 3 u by 2 I cap plus u by 2 j cap, and then also multiply 4. So we'll get 4 and 4 over here. So this is your final velocity. But they are saying the energy lost. So energy lost basically means, energy lost basically means, energy loss basically means that they want us to find out initial energy minus final energy, right? So if I'm going to talk about UA, magnitude of UA, that is simply equals to U, right? If I'm going to talk about UB, magnitude will be, my dear friends, this is going to become, this is U by 2 plus U by 2. So this will become under root of 2 U square by 4. So that means this will become U by root 2. Hopefully this is all clear to you, right? U by 2 whole square, U by 2 square plus U by 2 square. Clear? And then the next thing is, my dear friends, to find out this velocity, magnitude of this. So again, I can take out 4 common and I'll be left with 9u square plus u square. So that will be u by 4 and under root of 10. Clear? Under root of 10. So we are going to get half m u square plus half m u square minus half 2m into u square, and then you can solve this equation. Kindly solve it and let me know what is the correct answer. Be quick. Come on, my dear friends. This is 10. This is 10, right? Come on, come on, come on, come on, come on. Let's solve it. Let's write it as 8, right? I think you can take out 1 upon 2 mu square common. So you will be left with 1. You will be left with 1 by 2. You will be left with 1 by 2 mu square. So you will be left with 10 by 8, right? So 4, 4, 8, 8. So 1 by 2 mu square, and you will get minus 2. Is it clear? So 8 minus 10 is minus 2, and this will become 2 and divided by 4. So this will become 1 by 4. So mu square by 8. Mu square by 8 is the correct answer. Mu square by 8 is the correct answer. Is it clear? Done? Yes, D is absolutely correct. Very, very good. Come on, be quick. Any more doubt? Sorted? Kindly see. They collide completely inelastically, means they stick together. Then first we apply conservation of linear momentum. Then we are going to find velocity in vector form. Then we'll simply write down the magnitude using under root, right? And then we are going to do the same thing over here. And then finally, when they are talking about loss is always initial minus final. Loss is always initial minus final, right? Okay, now let's move on to the next problem. Come on, let's do this problem. Sub clear, very, very good. Robin, everything's clear? Tejaswini, good. Yash, good. Sir, give poll in question. Fine, okay, agreed. Agreed. Let me first read this question. A particle of mass m with an initial velocity u collides perfectly elastically with 3m at rest. It moves with velocity v j cap after collision. Then you guys can solve this question, right? Solve this question in homework. I don't, because it is an elastic collision, so there is no, I mean, there is nothing much left for me to help you on this one. An object of uniform density initially at rest explodes. Haan, chalo, let's do this problem. 90 seconds, let's start. Be quick. Quick. Done. Question is saying an object of uniform density initially at rest explodes. So initially at rest basically means that finally also center of mass should be at rest, because explosion happens because of internal forces. Finally also center of mass should be at rest. So if it explodes into two fragments of same uniform density, then kinetic energy of these fragments are in the ratio of 1:2. Okay. All right. First of all, if two fragments into two spherical of uniform density, fine. We are going to simply say that initial momentum was 0. I am applying conservation of linear momentum. Initial momentum is 0. Finally, momentum will be m1 into v1 plus m2 into v2. That means, okay, this is one relation. Second relation is that kinetic energy can be written as, the ratio of kinetic energy is Ke1 upon Ke2. It is m1 into v1 square upon m2 into v2 square, and this is actually given as 1:2, right? This is given as 1:2. So my dear friends, over here you can write down m1 into v1, I'm talking about the magnitude, is equals to m2 into v2. So m1 upon m2 can be written as v2 upon v1, v2 upon v1. So I don't know why I've written, ठीक है, 1/2 is fine. And instead of m1 upon m2, I can write v2 upon v1. No. Let's not do it. Let's write v1 upon v2. v1 upon v2 can be written as m2 upon m1. So we are going to get m1 upon m2 times v1 upon v2. So this we'll get m2 square upon m1 square, and this will get cancelled out, this will get cancelled out, and we are going to get 1 upon 2. And because these are spherical objects, because these are two spherical objects, that means we are going to write, instead of m2 we are going to write density into 4/3 pi into r2 cube divided by density into 4/3 pi into r1 cube is equals to 1 upon 2. These things can be cancelled out, and I think r1 upon r2 will be 2 raised to the power 1/3. So ratio is 2 raised to the power 1/3 is to 1. Clear? Any more doubt? Sorted? Be quick. Any more troubles, my dear friends? Everything's clear? Can we move on to the next chapter now, if collision is all done? Although yes, that's absolutely true, we can do some more questions on collision, but fine, I'll bring them in another class because we have got less time and we have to start our next chapter also. My dear friends. So we'll start with the concept of moment of inertia. Moment of inertia is analogous to mass. It is also known as rotational mass, right? And for us it is a scalar quantity. For a single point particle, its moment of inertia formula is mr square, right? R is the perpendicular distance. What are the other things? For 2-point masses, if you want to find out the moment of inertia from the center of mass, so first find out the center of mass, r1 and r2. Hopefully this is all clear. And mr square, right? This is important because they can ask you questions from these things, on what factors does these physical quantity depends. So moment of inertia depends upon obviously mass, right? It depends upon mass, axis of rotation, and mass distribution. In this entire chapter, axis of rotation is very, very, very important, right? I mean, please simply don't remember that moment of inertia is ml square by 3 or ml square by 12. Completely remember it, that moment of inertia of a rod about an axis passing through one of its edge and perpendicular to its length is ml square by 3, and perpendicular to its center of mass is ml square by 2, and so on, ml square by 12, and so on, right? Clear? All right. Now, for system of discrete particles, moment of inertia will be m1 r1 square plus m2 r2 square plus m3 r3 square, and so on, right? I'm moving on because hopefully there's no doubt in these basic formulas, right? Hopefully you guys can understand. Whenever there is a particular topic, I'll always explain. So right now I think we can move on, and now let's talk about things like, sorry, not this, my dear friends. Let's talk about first for continuous body. For continuous body, my dear friends, please remember that formula of moment of inertia is integral of r square into dm, right? And then very important theorem, parallel of axis theorem. It is, let's suppose we know the moment of inertia about an axis which is passing through center of mass. This is very important, right? It should pass through center of mass. It should pass through center of mass. Then moment of inertia about an axis which is parallel to this will be written by moment of inertia about center of mass plus m, mass of the body, and a is the separation between these two axes, right? So two axes must be parallel. One of the axes must pass through the center of mass. Must pass through the center of mass. So example, please remember this as mr square by 2. mr square by 2. Now let's suppose we want to find out moment of inertia about how to read this axis. That is the most important thing. How to read this axis. So we are going to call this axis as an axis which is tangent to the ring and perpendicular to the plane of the ring. Perpendicular to the plane of the ring. Perpendicular to the plane of the ring. Right. So let's suppose if this is let's suppose if this is the ring, it is perpendicular. It is actually, this thing is perpendicular to the ring, right? And this is in the plane. This is actually in the plane, right? So hopefully this is all clear to you. The moment of inertia of this will be written by moment of inertia about an axis passing through center of mass and perpendicular to the plane is mr square by 2 plus mass of the ring, and separation is r, so r square. So mr square plus mr square by 2 is 3r by 2 mr square, right? Now for this you will have to understand perpendicular axis theorem also. For this you will have to understand perpendicular axis theorem also, and I'm going to explain that to you. Acha, by the way, this is disk, that is the ring. This is disk. Let me explain this also. See, what you guys can do is, this is perpendicular axis, this is parallel axis theorem, and then there is another theorem which is perpendicular axis. But in perpendicular axis, what happens, that let's suppose if you have got a if let's suppose you have got a planar body and you have got two axes which are in the plane, of this planar body, and then one of the axes which is perpendicular. So let's suppose this is z, this is y, this is x. So iz will be written by ix plus iy plus iy. You can write it like this. All right, clear? You can write it like this. Be quick. Let me know if you have any other doubt. Sorted? And we can find out that 5 by 4 using this. Similarly, 2 mr square, and this is a tangent which is this is an axis which is tangent to the ring, and it is on the plane of the ring. This is tangent to the ring and it is perpendicular to the plane. This is ring, and it is perpendicular to this, right? So my dear friends, after this also do remember same thing for hollow cylinder. For hollow cylinder it is mr square. For solid cylinder it is mr square by 2. This will be 3 by 2 mr square, right? Now let me give you one question also on this. Let's solve this problem. Four equal masses m each are placed on the corners of a square, fine, and the moment of inertia of the system about an axis passing through point A. So if axis is passing through point A, there will be no moment of inertia about because of A, right? So net moment of inertia about an axis passing through point A will be, this will be 0, m into square of 0 plus m into square of L plus m into square of this distance is L root 2 plus m into L square, and that's it, right? Summation of mr square. So this will become 2ml square plus this will become 2ml square, that is 4ml square. That's it. So this was very simple. Sorry, this is actually 2. Is there any other trouble? M. So 0. this is L, this is L root 2. That's absolutely fine. Just a second, what they are saying, the moment is about an axis and parallel to dB. Oh, I'm so sorry. Parallel to dB. Parallel to dB. Okay. All right. Okay, fine. Just a second. Abhi, right now what I have done is I have found out moment of inertia about this axis, right? We have to find out moment of inertia which is parallel to dB. Parallel to dB. So that means it has to be in the plane. That means this is dB, and we have to find out not about this, but passing through A, an axis parallel to dB. So parallel to dB basically means this thing. This is the axis. This is the axis. All right. What would be the answer for this one, my dear friends? Be quick. Come on. Let me know the answer for this one. Friends. You know what you can do? You can find out the we can find out the moment of inertia about this point. Right? We can find out the moment of inertia about this point. I mean about this axis. About this axis. And this axis and this axis and the green one are perpendicular. Right? And both of these are in the plane and this is perpendicular to the plane. Right? But this is but that is for planar. This is not planar. Okay, fine. No problem. So I think we can directly do it. There is no doubt in this. From this axis, this we have to find out this distance. This is L, and this is going to be L root 2. Kindly check the answer. I don't know why we are not getting the answer. Let me see. Let me see, my dear friends. Let me see. Are you guys getting any answer? You guys getting any answer for this one? If you are going to talk about moment of inertia about this is about an axis passing through A and perpendicular to B and perpendicular to plane. In that case, I think we were getting our answer as our answer was absolutely correct. This is going to be ml square and this is going to be ml root 2. So ml root 2 whole square and plus that's going to be again ml square. So you are going to get 2ml square plus 2ml square. That means 4ml square. So we are getting final answer for this is, moment of inertia about this axis is 4ml square. But they are not asking about this axis. They are asking about this axis, this parallel axis. Come on, be quick. Do you have any idea? The moment of inertia of the system passing through A. I think, my dear friends, I think we'll have to find out the distance in this. you know what? We'll have to find out the distance of these points from these from this thing. That's going to be slightly difficult. That's going to be slightly difficult. I'm going to explain it to you. I'll try to explain it to you. B is at L root 2. So B will be at distance of B from the axis will be, this is L, and we want to find out the perpendicular distance. We want to find out the perpendicular distance. So this is going to become, this is perpendicular. So this is D. So this is dB. So this is going to be L by root 2. This is going to be L by root 2. So moment of inertia about the asked axis is mass m and into L square by 2 plus, and similarly from this also it will remain same. From this also it will remain same. So this will be also, this is also dd, it will be also ml square by 2 plus, so this will come out to be ml square. This will come out to be ml square, and this axis is root 2l. So this will be m into root 2l whole square. So this will be 2 ml square. My dear friends, answer is going to be 3 ml square. Answer is going to be 3 ml square. Correct, correct. We have to find out the distance from this perpendicular. If this is L, this is 90 degree, right? Then we are going to, if we are going to drop down a perpendicular, this is going to be L root 2. This is slightly different question, not for NEET exam, but yeah, but we can do it like this, 3 ml square. Correct, 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 correct. Now let's move on to the next question. 4-point masses, okay, and this is also a question on 3D coordinate system. Fine, we'll see. And then they are saying that calculate the moment of inertia of this specific configuration about the x-axis. About the x-axis, fine. So we have to find out the moment of inertia about the x-axis. About the x-axis. And points are, first point is my dear friends 1, 0, 0. So 1, 0, 0 B means that this point lies on the x-axis. 1, 0, 0. So for 2 kg, when I'm going to write down the final moment of inertia of system about x-axis, I'm going to write 2 kg multiplied by square of 0 plus 3 kg multiplied by, see, this point is at a distance of 2 meter from the x-axis. From 2 meter from the x-axis. Let's suppose this is origin. So this point is somewhere over here. That is 0, 2, 0. So this perpendicular distance is 2 meter. You have to always find out the perpendicular distance from the axis of rotation. So 3 into square of 2 plus, then they are saying 0, 0, 3. So 0, 0, 3 will be somewhere over here on the z axis, right? On the z axis. So that will be mass is 3 kg and 0, 0, 3 means 3 square plus mass is 4 kg times, and this is again on x axis, right? This is again on x axis, minus 3 and minus 3. Sorry, minus 1 and minus 3. So I'm going to write down square of 3. Solve it and find me the answer. Be quick, my dear friends. Be quick. That's it. You are going to get your answer after this. Clear? Everything is clear. Say yes or no. Right? Radius of gyration. Radius of gyration is another important topic. In this, they are saying we have got a hollow hemisphere. You have to match list 1 with list 2. And we are talking about radius of gyration. For a hollow hemisphere of radius are about an axis of symmetry. Right? Just now I have said that the center of mass of a hollow hemisphere is 2 by 3 mr square. right? It is 2 by 3 mr square. So if you have got a hollow sphere, not hemisphere, sorry, if you have got a hollow sphere, the moment of inertia is 2 by 3 mr square, right? 2 by 3 mr square about an axis passing through the center. Clear? But if you have got a hemisphere, the moment of inertia will remain same. Let's suppose the entire mass is m and radius is r, and let's say this is hollow hemisphere. This is hollow hemisphere, right? So you are going to apply the same rule over here also. The moment of inertia of this will be also 2 by 3 mr square and equals to mk square, where k is the radius of gyration. So this gets cancels out. K will be under root of 2 by 3 into r. Okay, clear, right? So in this manner you can solve this question. So option A will be marked to fourth one. Option A will be marked to fourth one. A thin uniform rod of length r about an axis passing through its center. So moment of inertia is ml square by 12, and that is equals to mk square. So k will be equals to L divided by root 2 or r divided by root 2. So this will match to option 1. Solid sphere of radius r about an tangential axis, right? So if you have got a solid sphere, and we want to find out the moment of inertia about this axis. Now we know this is 2 by 5 mr square. This distance is r. So moment of inertia about this axis will be 2 by 5 mr square plus mr square, or you can simply remember it as 7 by 5 mr square. So this is going to be 7 by 5 mr square. So that means mk square is equals to 7 by 5 mr square. So m and m get cancels out and k comes out to be under root of 7 by 5 times r. Under root of 7 by 5 times r. Under root of 7 by 5 times r. That means option 3. Which means that for a hollow cylinder that will be obviously equals to r, right? Because moment of inertia is mr square and that will be equals to mk square. So k is actually equals to r. K is actually equals to r. All right, clear? Any more doubt, my dear friends? Sorted? Let's also solve one or two questions on conservation of angular momentum. Acha, what about this question? Let's see this one. Let's see this question. This is also a nice problem. A thin uniform rod of mass m and length L has a moment of inertia of I about an axis passing through its center and perpendicular to its length. Fine. So you have got a rod of length L and mass m, and its moment of inertia is I. By the way, moment of inertia is I, we can write it as ml square by 12. We can write down it as ml square by 12, right? And then they are saying that if the same rod is bent into form of a complete circular ring, what will be the moment of inertia? Okay. So if you are going to bend it into a complete circular ring, let's say its radius is r. So its moment of inertia will be, mass will remain same, its moment of inertia will be mr square. But for r, I am going to write that since total length is same, so 2 pi r is equals to L. So r will be written by L by 2 pi, right? So moment of inertia will be m into r square, that means L square by 4 pi square. Now they are not giving answers in terms of m. So what I am going to do is, instead of ml square, instead of ml square, I'm going to write down over here as 12i. I'm going to write down over here as 12i. So this will become 12i divided by 4 pi square. So this will become 3i by pi square. 3i by pi square. This will become 3i by pi square. Clear? So 3i by pi square is option number B. Any more doubt, my dear friends? Sorted? Let's solve this question. Conservation of angular momentum is very, very important. Please remember, just like conservation of linear momentum, please solve multiple questions of conservation of angular momentum. Conservation of angular momentum basically says that let's suppose that net external torque is 0. Net torque can be also written as dl by dt. This will be 0. This basically means that the angular momentum of system will remain constant, and angular momentum can be written as in one more way, that is I omega. So I omega will be constant. And if you remember, NTA has asked multiple questions from this concept in past few years, right? So coming back to the question, I omega is constant, please remember. So a rotating system freely with an initial angular velocity of 18 radian per second. So omega I is 18 radian per second. 18 radian per second due to an internal reconfiguration. Internal reconfiguration basically means that net external torque will be 0. Net external torque will be 0. Net external torque will be 0, right? And because of this, angular velocity drops to, not drops by, drops to 2 radian per second. 2 radian per second. What is the ratio of initial radius of gyration to final? So simply we are going to write mk1 square into 18 is equals to mk2 square into 2, right? I have assumed mass to be m can be cancelled out. K1 upon K2 will be 18 upon 2 and root of this, that means 3:1. 3:1 is the correct answer. 3:1 is the correct answer for this question. Is it clear? Quickly write down in the chat box. Everything's sorted? Done? Similar question. Similar question, they are saying that in a uniform circular structural disk of mass capital M, so you have got a disk like this. You have got a disk like this, and this disk is rotating about this axis. With some constant angular velocity omega naught. A small dense piece of wax of small mass m, and this distance is r by 2, is gently dropped vertically and sticks precisely at a radial distance of r by 2 from the center. Still net torque will remain 0. Net torque will remain 0, right? No net external torque. So we are going to write I1 omega 1 is equals to I2 into omega 2. So I1 will be, my dear friends, mr square, because I have got a disk, please remember. So I am going to write mr square by 2, and instead of omega 1 I am going to write omega naught, and when it is going to stick I am going to write mr square by 2, and please remember for a particle I am going to simply use mr square formula. So mr square by 4, because now the distance is r by 2, so square of r by 2 becomes r square by 4, and this is omega f. That's what I want to find out, right? So my dear friends, I can get, if you will see, r square can be cancelled out, right? This will become 2, this will become 2, and then we'll have omega f equals to 4m into omega naught divided by 2 times of 2m plus small m. So this will get cancelled out and we'll get 2m omega naught. 2m omega naught divided by 2m plus m. That means option A is correct. Clear? Option A is absolutely correct. Any more doubt? Right? Now, although yes, indeed, we have done more questions in center of mass. In the next class, whenever our next class will be, I'll try to keep more questions on rotational motion also, right? But if you are going to do these many questions, your system of particles, this big unit, will be pretty much all covered, right? And these questions are best for your practice, right? Now, in the meantime, in between, there were 2 or 3 questions which were of really good level. So if you are not able to understand that, please again rewatch the explanation. Hopefully you will get it, right? So that will be all for right now. Thank you so much. I'll come back with another set of chapters after 2 days, and timing will be informed to you on this channel, right? Please kindly watch the community section of this channel regularly. So constantly we are having classes. It will be even better that if you are going to, in every class, for my class, for Ambika ma'am class, for Gaurav sir's class, if let's suppose you already know that in this class we are going to study gravitation, we are going to study mechanical properties of fluid or solids, please revise it once and then come into the class and solve with us in the live class. That will be very, very beneficial for you, right? With this, I'll take your leave.